Right, so in the next example, we're going to do another expected value problem. This time we're going to look at a couple of different scenarios. Maria is taking a multiple choice exam in which there are 5 possible answers for each question. The instructions indicate that she will be awarded 2 points for each correct response and that she will lose half a point for each incorrect response. No points will be added or subtracted for answers left blank. So, if Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess at an answer? Right, so what we're going to do, we're going to use our expected value formula. Okay, so, and our 2 probabilities are going to be that guesses correctly or guesses incorrectly. Right, so we have P1A1 plus P2A2. Right, so the probability that Maria guesses correctly there's 5 possible answers. So she has a 1 out of 5 chance of guessing the answer correctly. The probability of not getting the answer correctly is going to be the complement. Right? That is going to be 4 out of 5. So 1 out of 5 chance of guessing the correct answer, 4 out of 5 chance of not guessing the correct answer. So our expected value, right, we're going to take P1 times A1. So 1/5 times 2 points that she would get awarded, plus P2 times A2, right, 4 out of 5 times -1/2 because she loses half a point. So I'm going to go ahead and multiply out these fractions. This one here, remember if we're multiplying fractions, we just go straight across. So this is really 2 over 1. And so I'm going to put my little denominator in here. So if I multiply these across, we get 2 over 5, right, for our first fraction. If we multiply straight across here, we get minus 4 out of 10. That can actually be reduced. 2 over 5 minus 2 over 5 gives us 0. Right? Or we could rewrite that as a common denominator, however you want to work through it, or use your calculator for a lot of these calculations. So Maria's expectation is 0. So over the long run, she will neither gain nor lose points by guessing. So Maria's expectation is 0. So over the long run, she will neither gain nor lose points by guessing. Right. So now we're going to use the same scenario, but we're going to change it just slightly. If she can eliminate one of the possible choices, is it to her advantage to guess at an answer? So we're still going to have P1A1 plus P2A2. Okay. And so her probability of guessing correctly, well, if she can eliminate one of the incorrect choices, that means she only has 4 choices left. So probability of guessing correctly is going to be 1 out of 4. The probability of not guessing correctly would be 3 out of 4. Right? So we've just slightly changed our probabilities here. Right? So 1 out of 4 times 2, because she still gets 2 points for a correct answer. 3 out of 4 times -1/2. Again, if we multiply this out, again, that 2 is over 1. So 1 over 4 times 2 over 1. If we multiply straight across, that gives us 2 over 4 minus 3 over 8. If we multiply that one straight across, then we need to find a common denominator. So I'm going to multiply both of these guys by 2. to give us a common denominator of 8. So we have 4 over 8 minus 3 over 8, which gives us 1 over 8. Okay, so in this case, Maria's expectation is 1/8. So over the long run, she will gain 1/8 point each time she guesses. After eliminating one possible choice. So again, same scenario, slightly different probabilities, gives us slightly different answers. So if the expectation is 0, then nothing is either going to be gained or lost. Again, positive, we would be an expected positive value, and then it is also possible to get a negative expectation. We haven't seen that yet, but we will.